Following quantum physics to its logical conclusion reveals a reality that behaves like a cosmic accordion. The entire universe seems to open up, with our single world replicating into a series of infinite, identical parallel landscapes. At the center of this expansion sits a startling revelation. According to the math, you will never actually experience your own death. This concept bypasses spiritual afterlives and digital uploads, focusing instead on the probabilistic persistence of your conscious awareness. Because there is always a path where you survive, your awareness simply continues to follow it forever. Known as quantum immortality, the idea seems absurd at a glance. However, it is a coherent interpretation of our physical reality, one that destabilizes our basic assumptions about what we actually are. To understand the instability of the self, imagine a future where teleportation is the standard way to travel. You step into a pod, and every particle of your body and brain is scanned, mapped, and disassembled, only to be perfectly reassembled at your destination. Imagine booking a trip to Bermuda, but a system glitch runs the reconstruction twice at the landing site. Now suddenly, there are two of you. Both versions hold your exact memories, birthmarks, and preferences, and both believe they are the same person who entered the pad moments ago. Now consider if only one version arrived intact, while the other was reduced to a puddle of biological matter. Did you die, or did you survive? From the perspective of the survivor, everything went perfectly. But this paradox suggests that our continuous sense of self is a fragile illusion, an undefined thread that doesn't rely on being unique or permanent. The roots of this mystery go back to the early 20th century. Niels Bohr and his contemporaries realized that the classical laws of physics, the rules that govern falling dominoes and moving cars, completely break down at the microscopic level. Werner Heisenberg recalled the despair of those early years, walking alone through a park late at night, wondering how nature could possibly be so contradictory. At this microscopic level, reality isn't deterministic. You can't hit a particle and predict exactly where it will go. Instead, everything is governed by random probability. In the famous double-slit experiment, particles fired at a barrier with two openings produce a result that defies logic. When unobserved, a particle acts like a wave of probability, passing through both slits simultaneously to strike a back wall. It exists in multiple states at once, a condition called superposition. The mystery deepens the moment we measure the particle's path. The presence of a detector causes that wave of potential to snap into a single defined state. The particle chooses one path, and the wave-like pattern on the wall vanishes. Physicists call this the measurement problem. While measurement sounds like it requires a human mind, most experts see it as any environmental interaction, a particle simply bumping into another particle. This implies that reality remains in a fluid state of potential until it is forced to define itself. It leaves us asking why the universe seems to choose only one outcome when we look at it. In 1957, Hugh Everett proposed a radical solution. He suggested that the wave function never actually collapses. Instead of the particle picking a path, Everett argued we should accept the mathematics as a complete description of reality. Buried in Everett's notes was an idea that changed the scale of the problem. If the wave never collapses, it means every possible outcome happens. Reality doesn't choose a path, it branches. Every quantum transition in the cosmos, every spark on every star, splits the world into myriads of copies. This animation shows a single timeline striking a node and fracturing into a vast web of parallel realities. We only experience one outcome because we become entangled with that specific branch. In this view, the other outcomes aren't just possibilities. They are physical realities existing in parallel, non-interacting worlds. When we apply many worlds to our own mortality, the logic takes a terrifying turn. If every physically possible outcome must occur, then every possible outcome of your life, including your survival, exists somewhere on that tree. Consider any moment where you almost died. In countless other branches, you did. But your subjective consciousness can only exist in the versions of the world where you are still alive to experience them. This survival timeline maps out a complex web of outcomes. While most branches end abruptly in death, The math requires at least one thread to weave successfully through every hazard, riding the surviving nodes indefinitely. This creates a perpetual state of survivorship bias. Some version of your awareness will always be the lucky one, evading every cause of death and riding a wave of improbable conditions forever. Subjectively, you become immortal. Even if the physics of many worlds is wrong, we are still constantly splitting from our past. As our selves are replaced and our memories are recontoured over time, we drift further away from the people we used to be. The static self is a convenient fiction. In truth, your existence right now is the result of an absurd, beautiful improbability. Whether we live forever or vanish tomorrow, we are here on this specific branch of reality right now. Our job is to cherish these relationships and this landscape while we can, appreciating the sheer unlikelihood of having made it this far.